Hello everyone, my name is Nirup Doji from BE 4th year Civil Engineering, and today I'm going to show everyone how to design a simple beam using Abaqus and how to run the analysis. So before we jump into the designing and the analysis part, to talk a few things about the software. Abaqus is a suite of powerful engineering simulation software tools for finite element analysis and computer-aided engineering, developed by Dassault Systèmes under the SIMULIA brand. And Abaqus is widely used across various industries, including automotive, aerospace, and civil engineering for both linear and nonlinear applications. So the key features of Abaqus include structural analysis, which has the capabilities for static, dynamic, and thermal analysis, and multiphysics. Abaqus can perform coupled simulations involving multiple physical phenomena such as thermal, electrical, and mechanical. So there are various steps before designing the parts. So we first have to create the part of the structure that we want to design. So we can either select it from the dialog box or use this toolbox. So we have to first name the name of the part, and we'll name it as beam, and we'll click continue. So we have this workspace. We can use the rectangular shape to create our desired beam. We can use other shapes as well, so we'll use this. And to define the diameters of the beams, we'll use the diameter function, and here we will take the diameter, the length as 100, and we'll take the width of the beam as 15, after which we will then define the depth of the beam. So the depth of the beam, we'll take it as 25. So we now have this beam in 3D, and the next step we'll move on to defining the material properties of the beam. So we will define the mechanical properties, so in elastic behavior. So we have two components to define: the Young's modulus. So we'll take the Young's modulus and the Poisson's ratio of aluminium, which is 0.23, and then we will have to define the section. So now that we have the materials, we now have to define the section. So first we have to create the section. We'll take it as homogeneous, click OK, and then we will select the part of the beams that we want to define the section. So we want to define the section in all parts of the beam, so we'll just do that, and then we will have to assemble it. So since now we have only one part, creating one part, we will have to assemble it so as it is. But if we have different parts, we have to assemble all of them together into their required position. Then we'll have to define the step. We have to create the step which we will be requiring during our analysis. We'll take static, general, and we'll describe the name of the analysis. We'll take it as load on the beam, and we'll click OK. After which we will then define the load conditions and the boundary condition. So we'll first define the boundary condition. We'll take the fixed support on the end. So we'll design it as a cantilever beam, which is fixed on one end. So we have to rotate it to select the surface of the beam. So we'll select the surface of the beam, and then we'll define the fixed condition, and there we have it. And then we will create the load, uniform area load. We'll take it as area load. So we'll take pressure, and we'll choose the surface we want to define the load on. Then let's say 0.5, and then click OK, and we now have our loading and boundary condition. So after which we will have to create the mesh. So we have to select the approximate size of the mesh, and first let's take it as 10, click OK, and then we'll mesh the part. So this is the meshed diagram of our beam. We can reduce the size of the mesh. For that we have to first erase the existing mesh and then create the new mesh. So we'll have, let's say, take it as 5, click apply, OK, and then we'll create the mesh. So as you can see now, the size has reduced, so there are more number of elements on our beam. So after which we will create the job, and now our beam is ready for the analysis. So we'll click on job, we'll name the job, let's give it as beam tutorial, and we'll click continue. Let's click OK. We'll click on the beam tutorial and we'll right click on it and click submit, after which we'll have to wait for some time for the analysis to complete. We can monitor the process if you want to by clicking monitor, and now we have completed our analysis. So to see the result, right click on it and click results, and then we can have the results. So click on the plot counters on deform shape, and we can see the stress concentration on the beams, the variation stress concentration. The red defines the highest amount of stress distribution. We can also check out the animations of the stress distribution, and we can also see the reaction forces on the beams, and we can also see the displacement on the beams. So as you can see, the displacement is more towards the end part of the beam. And so this is all for the basic tutorial for designing a simple beam using Abaqus. Thank you for watching.